Assalamu alaikum. So the second lesson on functions is about composite functions. So the composite functions are the combination of two or more functions. That means when we combine two or more functions, we get a composite function. Meaning if I say that the function is f of gx, then this is a composite function, which means apply g first, which means apply g first followed by f. In the same manner, if I give you a function which says it's gf of x, then that means apply f first followed by g. So what does this function mean? This function means that this composite function, it means that let's say it's f of x, which is equals to 3x plus 2. And there is the given condition that x belongs to all real numbers. And you are given another function, and let's say that another function is g of x, and this is equal to 7 minus x, where again x belongs to all real numbers. So if I tell you to find fg, then simply what fg means is, in the function f, in place of x, I will be substituting the function which is g 7 minus x, and this is equals to 3x plus 2. Meaning, in the place of x, I will be substituting the function g here. So this means f of g will be equal to 3 times 7 minus x plus 2, or solving it, I can say f of g is equals to a 21 minus 3x and a plus 2, or I can say that this is a 23 minus 3x. So this is what your function fg is going to be. In the same manner, if I tell you to find gf, then for gf, I should know that in the function g, I will be substituting the function f, which is 3x plus 2. I know the function g is 7 minus x. So g of f then will be equal to 7 minus, in place of x, I will be substituting the function f, which is a 3x plus 2. Solving it further, I can say this is 7 minus 3x minus 2, or this can be equal to 5 minus 3x. So this is what function gf is going to be. I can also tell you to find, this was the first example, this was the second example. Now let's do the third example. Let's say find f square. So f square means it should be the function in two function. So that means it's the function which is combined with the composite function, which is 3x plus 2. That means for 3x plus 2, in place of x, I will be substituting 3x plus 2 again. So that means my f square is going to be 3 times, in place of x, substituting f again, it's 3x plus 2 and a plus 2, and so f square will be equal to a 9x plus 6 and a plus 2, or f square or f into f will be equal to 9x plus 8. With all these examples, I can also say solve the equation gf of x, which is equals to 2x. Again, let's say that the function that was given to us was the function g, or in fact we did find gf in the beginning, and we said that gf was the function which equals to 3 minus x. So gf was equal to 3 minus x, 5 minus 3x. So gf equals 2x. I got gf, which was 5 minus 3x. I'll just equate it to 2x and I can say it's 5, which is equals to a 5x. 2x plus 3x will be a 5x. Or I can say that in this case, the value of x equals a 1. So this is how I can even solve the equation with respect to the given condition here. So the question that we have is the function f and g are defined for x belonging to all real numbers by fx, which equals 4x minus 1, and gx, which equals 2x plus k, and we need to find the value of k for which g of f equals f of g. So this means in this case, I'll be first finding out g of f. So g of f means if my g is equal to 2x plus k and my f is equal to 4x minus 1, then so to get the solution for gf, I will just be substituting in place of x the function f, which is 4x minus 1, and then it's going to be a plus k. So I can say g of f will be equal to 8x minus 2 and a plus k. In the same manner, I will find fg. So for fg, in place of x, in the function f, 4x minus 1, in place of x, I will be substituting 2x plus k, and then it's a minus 1. So fg is going to be an 8x plus 4k and a minus 1. So the given condition says it's g of f that should be equal to f of g. This is the given condition in the question. So I shall say that this is 8x minus 2 plus k, which shall be equal to 8x plus 4k and a minus 1. Solving it, I can see 8x gets simplified. I will be left here with a minus 2 plus 1, which is equals to 4k and a minus k, or I can say it's a minus 1, which is equals to 3k, or k is equals to a negative 1 by 3. So this is how I will just solve the equation to get the value of k. So the next question is f of x, the function f is 3 minus x, g of x is x squared minus 19, h of x is x minus 2 for x belonging to all real numbers, given that f of x equals g of hx. Now f of x equals g of hx, which is a composite function. So find the values of x. Again, just be very specific here, be very vigilant here that the question is asking for values of x, meaning there are going to be more than one value of x here. So how to start solving it? The first thing is to find the composite function g of h. So g function is equal to x squared minus 19 and h function is equal to x minus 2. So if I find g of h, then just in place of x, I will be substituting the function h, which is going to be x minus 2 the whole square and a minus 19 here. Which means if I solve it further, then g of h is going to be x squared minus 4x plus 4 and a minus 19. Or I can say that my g of h is going to be x squared minus 4x and a minus 15. So this is my composite function gh. Now the given condition is fx is equal to gh of x. This is the given condition, and through this condition I will be finding out the values of x, or to solve the equation. So f of x is 3 minus x. So if I just plug in this 3 minus x here and equate it to gh, which we just found as x squared minus 4x minus 15, I can see that I am getting a quadratic equation, which then can be written as x squared minus 4x plus x minus 15 minus 3, which is equals to 0. Or I can say this is x squared minus 3x minus 18, which is equals to 0. And doing the factorization, I can go for x squared minus 6x plus 3x minus 18, which is equals to 0. X common, I'm left with x minus 6 plus 3 common. Again, left with x minus 6, which is equals to 0. Or I can say that this is x minus 6 and x plus 3, which equals a 0. And from here, I can see that I'm getting two values of x. One is a negative 3 and the other is a positive 6. So these are the values of x for which the function f shall be equal to the composite function g of h here. Next question that we have here is for the function f and g, which are defined for x belonging to all real numbers, such that f of x equals a minus x, g of x equals x squared plus ax plus b. And given that we have the condition that f of g of minus 1, meaning whatever the composite function f of g, x value has to be a minus 1, and that should give us the function value which equals a negative 1. And g of f minus 1 equals a negative 1. So find the values of a and the values of b. Just be specific that they are asking for the values. So that means there may be more than one values of a and b. So starting with the first given condition, which says that it's f of g minus 1, which is equals to minus 1. So let's first find f of g. Our function f is a minus x and our function g is x squared plus ax and a plus b. So to find f of g, I should be substituting in the function f g in place of x. That means I will be having here a minus bracket x squared plus ax plus b. So in place of x, I have substituted the function g. So f of g, solving it further, should be equal to a minus x squared minus ax and a minus b. So now the condition says that f of g minus 1. So f of g minus 1, substitute f of g with the x value as minus 1, I will say this is minus 1 the whole square minus a times minus 1 and a minus b, or I can say this is a minus 1 plus a minus b, or I can say that f of g minus 1 is equal to 2a minus b and a minus 1. Again, the given condition states that f of g minus 1 should be equal to a minus 1. So I do have f of g minus 1, equating it to a minus 1. I will be getting 2a minus b minus 1, which equals a minus 1. So minus 1 on both the sides gets cancelled, and it's 2a minus b, which is equals to 0. Or in other words, I can say that b is equals to 2a. So this is our b in terms of a with respect to the first condition, which said f of g minus 1 equals a negative 1. Now we have to solve for the second condition, which states it's g of f minus 1 equals minus 1. So g of f minus 1, which equals a minus 1. We had the g function, which was equal to, so the g function was equal to x squared plus ax plus b, and we had the f function, which was equal to a minus x. So for g of f, in place of x, I will be substituting the function f here. That means I should be getting a minus x the whole square plus a times a minus x, and then I have a plus b. So I will be having here g of f, which will be equal to a square minus 2ax plus x square plus a square minus ax and a plus b here. Or solving it further, I can say this is a 2a square minus 3ax plus x square and a plus b. Given condition stated that it should be g of f minus 1. That means I will be substituting x with a minus 1, meaning I will be getting a 2a square minus 3a. In place of x, it should be a minus 1 and then plus 1 minus 1 the whole square and a plus b. Solving it further, it's a 2a square plus 3a and a plus 1 and a plus b. So this is our g of f minus 1. Again, if we'll go back to the condition, what we can see is that this g of f minus 1 was equated to a negative 1 also. So I will be equating 2a square plus 3a plus 1 plus b to be equal to a negative 1. So 2a square plus 3a plus b and a plus 2 shall be equal to 0. Now, when we solved for the first condition, we got b, which was equal to 2a minus 1. So I will be substituting b as b equals 2a. So I will be substituting b as 2a. So b was equal to 2a. This was the condition that we had. So I can say it's a 2a square plus 3a plus 2a plus 2, and this equals a 0. Or I can say it's a 2a square plus 5a plus 2, that equals a 0. Again, factorizing it, I can say it's a 2a square plus 2a plus 4a. In fact, it's the middle term break that I should be doing. Plus a plus 2, that should be equal to 0. 2a common, I will be left with a plus 2. Plus 1 common, I will be left with a plus 2, which is equals to 0. So from here, I will be getting two values of a. One of the value shall be equal to a negative 2 and the other value shall be equal to a negative 1 by 2. So these are the two values of a that I can get. So for the values of b, I can say that b was equal to 2a. Therefore, just substitute the values of a that we have obtained. So b value then will be equal to 2 times minus 2, which is a minus 4. And also I can say that b is equals to 2 times a, which is a negative 1 by 2. So b is equals to a negative 1. Therefore, the set of values of a and b can be when a is a negative 2, b was a negative 4. When a is a negative 1 by 2, b was equal to a negative 1. So these are the set of values of a and b that I can get with respect to the given condition here. So now we know how to form composite equations and how to solve them also. So with respect to that, however, we must know that there exists a condition for the composite function to exist, and that condition is that for a composite function, let's say that that composite function is f of g, then for this composite function fg, it only exists, fg will only exist. So this is the validity condition for the composite function. It will only exist if the range of g, is contained, meaning it's the range of g that should be less than range of g that should be lesser or equal to the domain of f. So for a composite condition, that is only going to exist if for a composite function fg, the range of g is lesser or equal to the domain of f. If the function would have been g of f, then this will only exist if the range of f, meaning all the y values of f, the range of f are contained or lesser or equal to the domain of g here. So this is the condition that needs to be highlighted. This is the condition that one should know for a composite function to exist. There is one more condition also, and that condition is, like, you might also say that it is the domain of G, that if you have the function fg, if there exists a function fg, then in this case, we should know that it's the domain of G. We are just doing the opposite now. It's the domain of G must be, meaning it should be lesser or equal to the range of fg. So these are the two conditions which one should know with respect to a composite function. In other words, if the question was in terms of gf, let's change the order. Let's say it's the function gf. Then in this case, I should know that it's the domain of f, which should be lesser or equal to the range of gf. So let's do questions with regarding the two conditions here. To explain the concept further about the validity of the composite function, or the conditions which must confirm to have a composite function, let's do the question which is from October-November 2015, variant 3, paper 1, and this is question number 8 here. So the question says the function is defined by f of x, which is equals to 3x plus 1. So let's write the function fx, which is equals to 3x plus 1, and they have given us the domain for the function which is x to be lesser or equal to a, where a is a constant. So we have these two conditions, fx 3x plus 1 with the domain as x to be lesser or equal to a. And then we have the function g, which is minus 1 minus x squared, and this also has a domain which is a negative, x to be lesser or equal to minus 1. So find the largest value of a for which the composite function can be formed. So largest value of a for the composite function gf can be formed. So they are asking for the composite function gf to be formed. So if that is the case, then what we should know is that we have discussed the two functions for which we said that it should be the range of the first function, which should be less than or equal to the domain of the followed function. So in this case, the range of the first function is f. The range of the first function is f. So for f, if I solve for f, then what I know is that f of x was equal to 3x plus a plus 1, and the domain was x to be lesser or equal to a, meaning if I substitute f of a here, then I should know that the range should be equal to a 3a plus 1. So range of f is equals to 3a plus 1 here. So the given condition states that the range of f should be lesser or equal to the domain of G. So what was the domain of G? If we look at the question, then in the question the function was G, which was equal to minus 1 minus x squared, and the domain for the function G was for x to be lesser or equal to negative 1. So in this case, I can see here that the range is for the first function f is 3a plus 1, and this should be lesser or equal to the domain of G, which is lesser or equal to minus 1. So I can just substitute this with a negative 1, so that I can say that it is 3a lesser or equal to a negative 2, or a shall be lesser or equal to a negative 2 by 3. So the composite function can only exist if the values of a shall be lesser or equal to negative 2 by 3. And this is what the question asked us for. Find the largest value of a for which the composite function. So if a is lesser or equal to negative 2 by 3, then a to be lesser or equal to negative 2 by 3, I can see that negative 2 by 3 is here. It needs to be lesser or equal to negative 2 by 3. So the largest value of a that should exist is actually equal to a negative 2 by 3. Set of values of a are lesser or equal to negative 2 by 3, but the largest value of a is going to be a negative 2 by 3. It's the largest value of a. Now let's do the second part. The second part says, for the case where a is a negative 1, now they have given us a as a negative 1, solve the equation f of g plus x. Now we have a which equals a negative 1, and we need to solve the equation which is f of g of x plus 14, which is equals to 0. So let's rewrite all the function values. I know that the function values are, number 1, f of x was equal to 3x plus 1, where for the domain x to be lesser or equal to a and a is a negative 1, I should say that it's x which should be lesser or equal to a negative 1. So g function was minus 1 minus x square, which was for x to be lesser or equal to minus 1. So I need to have f of g first. So f of g of x shall be equal to, in the function f, in place of x, I will be substituting g, which is minus 3 minus x squared, and then there was a plus 1. So solving it, I can say it's a minus 3 minus 3x squared, and then it's a plus 1, or I can say that the function f of g of x is equal to negative 2 minus 3 x squared. So according to the question, they have said that f of g of x plus 14 was actually equal to 0. This was given in the question. So if this is given in the question, then just substituting the composite function f of g, I can say it's a minus 2 minus 3x squared plus 14, which is equals to 0, or minus 3x squared plus 12 equals a 0, or I can say that it is a minus 3x squared, which equals a negative 12. Solving it, I can say x squared is equal to a 4, or x is equal to a plus minus 2. So x is equal to a plus minus 2. Now I need to consider the condition here which says x should be lesser or equal to minus 1. So that was the given domain that we had with respect to the domain condition. We had x is lesser or equal to minus 1 for the function f. G was also having the same domain, which is lesser or equal to minus 1. So here I cannot say that x should be equal to a positive 2, because positive 2 is not lesser or equal to minus 1. But for this condition, I know that the x value has to be x equals a negative 2. So this is going to be my final answer here. X equals a negative 2. Third condition, which is for 4 marks, that says find the set of values of x which satisfy the inequality. Now we have the inequality which is g of f of x, which should be lesser or equal to minus 50. So here again I need to have the composite function gf. So f was equal to 3x plus a, 3x plus 1. The function g was equal to minus 1 minus x squared. So to find gf, in the function g, I will be substituting the function f in place of x. So this becomes 3x plus 1 the whole square. Or I can say it's g of f, which is equals to, I'm just taking the negative common, so that I'm left here with 1 plus 3x plus 1 the whole square. So g of f of x is lesser or equal to minus 50. Substituting g of f, I can say it's a negative here, and we have a 1 plus 3x plus 1 the whole square, which is lesser or equal to negative 50. I can solve the negative signs on both the sides, but having an inequality, I know that if I solve the negative signs, the sign of the inequality changes so that this becomes greater or equal to 50 here. So again, I can see that this is 3x plus 1 the whole square, which is greater or equal to 49. 50 minus 1, that gives me a 49. So what I know here is that we are talking about a quadratic curve, which is having a minimum nature. So this is having a minimum nature. All right. So we have the condition for the function f, and that condition says for both of the functions, in fact, and the domain of the functions they have said shall be equal to x lesser or equal to minus 1. So just keep that in mind. Whatever domain we have to consider, we have to make sure that our x is lesser or equal to minus 1 here. So let's solve the equations. This was 3x plus 1 the whole square, or let's take the under root on both the sides. So if I take the under root on both the sides, I should say that 3x plus 1 shall be equal to a plus minus 7, or it's 3x which is equals to 7 minus 1, and also 3x which is equals to minus 7 and a minus 1. So 3x here shall be equal to a 6, or x shall be equal to a 2. And here in this case, it's 3x equals a negative 8, or x equals a negative 8 by 3 here. So I have the two conditions, the two roots with respect to the x-axis. One is a negative 8 by 3 and the other is a positive 2. So here I can see that we are talking about the inequality which states that it is greater or equal to 50, or if I take the 49 on the other side, this is greater or equal to 0, meaning the region that we are talking about has to be above the x-axis. This is the region that we are talking about. With the domain which states that this has to be x lesser or equal to minus 1, I am not going to consider the side which is for x to be greater or equal to 2, because that does not lie in the given domain. So the value of x that should be the answer here is with respect to a negative 8 by 3, and I should say that x less than negative 8 by 3 is satisfying GF lesser or equal to 8 by 3 here. So this is going to be my final answer. X is lesser or equal to 8 by 3. So just make sure it's just not about giving the answer, but also check the domain whether the answer that you are getting are lying within the domain or not. That is very important. You shall not be giving both the answers. You have to consider the domain also, and you have to check the validity of each and every function value or the domain value that is given to us. So which will lead you to the final answer. So this is going to be the final answer here. So the next question with the same concept that we have done for the validity of the composite function, that is from year 2018. It's summer paper, variant 2 and paper 1, and this is question number 10. So here function f and g are defined by 8 over x minus 2 plus 2 for x to be greater than 2, and we have the function gx which is equals to 8 over x minus 2 plus 2, and the domain is from 2 less than x less than 4. So we can see that the two functions are the same except that the domain is different for both of them. Function f has the domain x to be greater than 2. Function g has the domain for 2 till 4. 2 is less than x, which is less than 4 here. So state the range of the function f. So for function f, unless and until you don't have the concept of getting the sketch of the function, you won't be able to find the domain of the function here. So what I know here is that f of x, our f of x is equal to 8 over x minus 2 and a plus 2. And in the beginning of the functions, we said that a function is only valid if it has a defined value. That means if I substitute x as 2 here, if I substitute x as 2, obviously I will be getting the function value, which shall be equal to 8 divided by a 0 and a plus 2. Any number divided by 0 is an undefined function. It's an infinity. It's an undefined function. So that is the very important condition that we should follow when we have an x in the denominator. So here I should say that my x value should not be equal to a 2 because I want a valid function. And that also means that if I sketch the graph here for the function, a rough sketch of the function, given function here, then here I should say that x2 is not going to be a valid function. So here my function is becoming an undefined function. It's an asymptotic function at x is equals to 2. So asymptotic function, and also they have said that x needs to be greater than 2. So that means all the function values, that means the curve has to be ahead of the 2 over here. X is greater than 2. This is the given domain that we have for the function. So if I have this as my function, then the next thing that I should know is that I should be having a range to it also. If the given domain is for x to be greater than 2, then what is actually going to be the domain here? So to get the domain, what I should say is, what I should say here is that I have the constant in the equation, which is a 2. I have the constant in the equation, which is the 2. So therefore, my y-intercept or the y-asymptote here shall also be equal to a 2 here. That means the curve that I should be having, this curve here. So if this is the case, if this is the curve that we have, then to get the range of the function, what I can see is that all the function values, they are greater than 2. So very easily I should say that for this function, it's f of x that needs to be greater than 2 here. So this is going to be the range of the given function. When x is greater than 2, I should be having my range to be greater than the function also. Now, with respect to the range of the function g, we have discussed that g is the same function, but it's just that the range, the domain value is between 2 and 4. That means if I just get the g function sketched here, then I know when x is a 2, it's the asymptotic value, which is giving me x as 2, and we know the reason. Reason is if x equals to 2, our function is becoming undefined. Therefore, at 2, it's an asymptotic function, for which we should say that the curve is becoming asymptotic there. The constant again is a 2 in the equation. Therefore, the y asymptotic line is going to be for y equals 2 here. Now, in this question, with respect to the domain that I have, I should be having the value for f of 4 also. So if I substitute my x as a 4, I should be getting 8 divided by 4 minus 2 and a plus 2, which shall give me the range value as 8 divided by 2, which gives me a 4 plus 2, and that is equal to a 6. That means if my x is a 4, then my range value is going to be a 6 here. Let's mark an exaggerated value, 6 here. So 2 is asymptotic, 2 is undefined, meaning the curve starts here, and when x is a 4, this is where it should end. My curve starts here, and when x is a 4, this is the point at which it should end here. So what do I notice about the function? I notice that for this value, for this curve, I am having the range, which is the range of g, and the range of g says that it should be the value of y such that it is all greater or equal, just greater than 6. just greater than 6, because I have seen that the inequality given to us says it should be 2 less than x less than 4. So 6 should be having just the greater than sign, not with is equal to. So g is greater than 6. That is going to be the final answer. So just a 1 mark question, but require a lot of understanding here. To solve the C part, it says state the range of the function fg. Again, we are talking about the composite function. We discussed two conditions when we were doing composite functions, and the two conditions were, number one, the first condition was range of g should be lesser or equal to the domain of f. And the second one said that if the function is fg, then the domain of g should be lesser or equal to the range of fg. In this condition, they are asking for the range of fg. So for that, I should say that domain of g should be less than the range of fg. That means for the composite function to exist, the domain of g that we had was 2 less than x less than 4. This was the domain condition that we had. 2 is less than x less than 4. So just by understanding, I should say, following the second condition for the composite function to be valid, I should say that for this question, domain of g is 2 less than x, which is less than 4. And this is the range, this is going to be the range of fg that has to be there so that the composite function can be formed. So this is going to be my answer here. Explain why the function gf cannot be formed. So why the function gf cannot be formed? Let's get the domain and range of the function f of x. So for f of x, we said that the domain was for x to be greater than 2, and the range that we found for f of x also said that f of x needs to be greater than 2. And if we consider the function g, then for the function g, we had the domain which was 2 less than x, which is less than 4, and we had the range which is for, what was the range of f? It was g to be greater than 6. So we had g to be greater than 6 here. So explain why the function cannot be formed. For this, I can see that the range of g is fx greater than 2, fx greater than 2 should be lesser or equal to the domain of the function g. So that should be domain of function g. So it's 2 greater than 2. We can see that for this function here, the domain was just between, the domain of g was just between 2 and 4. The domain was just between 2 and 4 for g, 2 and 4 for g, whereas the range of f was just greater than 2. So obviously just greater than 2, that gives a very open question, and therefore we are going to say that g of f cannot be formed because the condition does not follow here. So we can say that the range of f does not lie within the domain of g. Therefore, g of f cannot be formed. So this is all about composite functions, and in the next video, we'll just move on to the next topic on functions then.